Right, speed, time, distance this time. There is a relationship between all of these things. Um, if you think about if you're in a car or on a train or something and you're traveling along, um, the faster you go, the less time it will take you to cover the same distance. If you allow more time, you can cover more distance. And if your distance is longer, it will take you a longer time to get there, providing you go at the same speed. So all these three things are tied up together, and we've got to know how to work out any one of them given the other two. Yeah. Um, so the way to do this, or one of the ways, is to draw a speed, time, distance triangle. Speed, time, distance. Yeah. Now, it doesn't matter how many times I've done questions like this. As soon as I see one, I'll just draw the little triangle. It jogs my memory about what to do. Or, in fact, once you remember how to do the triangle, you can forget all the formulas of how to work things out because it's all there in the triangle. And obviously the D is for distance, the T is for time, and the S is for speed. This tells you how to work out any one of the three. So if we take the top one, the distance equals these two timed together. Speed times time. Remember, we don't need to put a little multiply in there. Yeah, I no need to write it longhand. Distance equals speed times time. I will. Distance equals speed times time. Now, what about if we want to know what the speed is, right? The speed is equal to the distance, and this is a divide in there. That's a little divide sign, yeah? The distance divided by the time. So the speed is the distance divided by the time. And the third one is if you want to know the time is the distance divided by the, I don't know if they do that in a different colour, whether it makes any difference or not. Yeah, a little divide sign there and a multiply sign there. So the time is the distance divided by the speed. So time is equal to the distance divided by the speed. Yay! Okay, so those are the three. There is, when you get into it, there is a way that you can just remember one and you can sort of move all these letters around to work out the other thing. But ooh, dangerous algebra. Nobody likes algebra very much, but you do because you're here listening to this. So we've got three little things that can help us out. Three little things that can help us out. So say we're going from London to London. That's because I wrote two. My brain was quicker than my head. London to Leeds. Yeah, it's very nice up in Leeds, and it's very nice down in London. Depends on where you are. Yeah, London to Leeds, and we'll say that's 400 miles. I know it isn't. It's all right, but I'm just guessing. It's about 250, maybe less. 400 miles, right? And you're going to travel at, what should we do? Should we do 60 miles an hour? 60 miles per hour. Look at that. mph, miles per hour. Could also be written as 60 miles per hour. Per means of, as in 100%. Yeah, 50%. 50 per cent. Yeah, 50 hundredths as a fraction. So we've got 60 miles per hour. How long? How long does it take us going to get there? How long? Right, so first of all, let's do our little triangle. And we're going to go, I'm going to go small letters down here. So we need to find how long, which is the time, which is this one. So the time is equal to the distance divided by the speed. The distance is 400 miles. The speed is 60. So if we just do 400 divided by 60, which is 6.6, 6.7 hours, something like that. 6.7 hours in decimal. Now remember, we did this before, 6.7 hours. I know it's 6.66, I've just rounded it up. Now, decimal, we can leave that, that's safe, 6 hours. And this one, we can do 60 times 0.7. 60 times 0.7 gives me 42. So that equals 42 minutes. Yeah, so it's 6 hours and 42 minutes to get from London to Leeds if it were that distance and we were going at that speed. Right, so that's finding out how long. Okay, so now we're going to go from Liverpool to Leeds. Like going to Leeds, it's nice up there, yeah. Now, how long? Fast, right? So it's the distance. Distance is 80 miles, and it takes us 2.5 hours. All lovely decimals, yeah, which would be 2 hours and 30 minutes. But we need to convert that 30 minutes into 0.5 of an hour. So it would be 30 divided by 60 would give us 30 divided by 60 would give us the 0.5, half an hour. How fast or how slow? Don't know. So we do our triangle, which is speed, time, distance. So we need to know how fast, which is speed. So the speed equals the distance divided by the time. Now the distance is 80 miles, the time is 2.5 hours, and 80 miles divided by 2.5 hours is 32. 32 what? 32 miles per hour. Busy on the motorway. Busy on the motorway, yeah? So we've found out the time. We've found out the speed. What about having a go at the distance? Having a go at the distance. So we're going to travel at 2 meters per second. Oh, that's a speed for 30 seconds. Now, this is the only problem. I don't think it comes into functional skills too much, but when you start mixing up seconds and minutes and meters and kilometers and it gets a bit of a nightmare because you've got to do all those conversions first before you start multiplying. See the last lesson or the one before. So we're traveling at that speed for 30 seconds. How far can we go? Okay, how far? Right, so triangle once again. Of course, if this was paper, you'd only need to do it once in the corner, wouldn't you? So now, how far? Distance. Remember, the distance equals the speed times the time. I'll put the multiplier in there. So the speed is 2. and the time is 30, which equals 60 what? 60 meters. So we could travel for 60 meters. 30 seconds to travel 60 meters. We're not going very fast, are we? Anyway, so that's it. So watch out for the notation, and then we'll have a look at some others. So this is the notation type questions. Liam runs 200 meters in 25 seconds. What is his speed in meters per second? So this is meters per second. So how many meters can he do in 1 second, basically? So we've got 200. We'll divide that by 25, which equals 8. So for every second, he can travel 8 meters. So it's 8 meters per second. Tina completes a 26-mile marathon in 150 minutes. What is her speed in miles per hour? Now, look, here we've got this mess of minutes and hours. So, I'm going to convert 150 minutes to hours first. Now, 1 hour is 60 minutes. 2 hours is 120 minutes. So it's 2 hours and 2 hours and 30 minutes. 2 hours and 30 minutes, which is 2.5 hours. Now, I've done that there because the answer's got to be in miles per hour. So you can do 26 miles in 2.5 hours. What's the speed? So we need the little triangle, don't we? So we're going to do the speed, the time, and the distance. Got to work out the speed. So the speed equals the distance divided by the time. The distance is 26 and the time is 2.5. So what's your speed now? 26 divided by 2.5 is 10.4. 10.4 miles per hour. That's pretty good going for running. 10.4 miles an hour. Right, got another one. Right, here we go. Right, don't forget you pause these, as I always say. Pause them and have a go, and then see whether we get the same thing. Now, Dimitri is planning a car journey. He's sketched the roads that he could take. There we go. He can go from A to B, B to C, all the way round from A to C. So you've got 2 routes. Dimitri will obey the speed limits. So the speed limit A to B is 50. Road from B to C is 20. Road from A to C is 70. Which is the fastest route from A to C? Right. Oh, don't we need this triangle to help us along with that? Speed, time, distance. So we need to time these 3 little routes. So this one, the AB, has a speed limit of 50. So we need to know the time for this part. So the time is the distance divided by the speed. So A to B is the distance is 80. The speed, he can only go 50. So we'll do that. 80 divided by 50 is 1.6. 1.6 hours. And I'm going to leave it as that, 1.6 hours, because we all we have to do is compare the two. So B to C, the distance, and we're going to find this time, yeah? Distance divided by the speed. So the distance is 10 and the speed is 20. So that equals 0.5 hours. And add these two together will be 2.1 hours. Okay, 2.1 hours. Now the other way, from A to C, the distance is 154 miles and you can travel at 70 miles an hour. So 154 divided by 70 is 2.2 hours. So this way, this first route is the fastest. 2.1 is shorter than 2.2. See, there was no need to change it into minutes. That will do. So fastest is A to B to C. Now, what's happened now? Dimitri decides to take the route that passes through B. That's fine, yeah? He sets off from point A. After 1.5 hours, his car breaks down. If he travels within the speed limit, what's the farthest he could have travelled? Right. So he's going from A to B, and the speed limit is 50 miles, and we need to know the distance. So the distance is the speed times the time. So the distance equals the speed times the time. Right, so the speed is 50 miles an hour. Yeah, so 50 times the time is 1.5 hours, which is 1.5 hours, which is 75 miles. That's the farthest he could have travelled. Okay, that's a good one. Speed, distance, time. Only way you can do these is to remember that triangle or draw it out every time. Yeah, and try not to get too hung up on seconds and hours and minutes and things, because they will challenge you, but maybe not. Maybe we'll be okay. So that's that one, and thanks for watching. See you in the next one.